hackers are hacking headphones, and you may be thinking, what? Is that even possible? And that's what I thought when I first heard this topic. The idea of hacking a pair of headphones, how could you do that? Why would you do that? And what is the worst thing that can happen? This story picked up some steam when an article about a week ago came up that says Apple fixes Beats Studio Buds flaw that allows hackers to spy on conversations. When I saw that, I was like, okay, like maybe there's like an RCE bug in like this one model of headphones, okay, not a big deal. But the rabbit hole on this goes really deep, and I'm honestly shocked more people aren't talking about it now or weren't back when this happened, which wasn't recently. For context, right? Apple makes these things called Beats Studio Buds. I don't know when the acquisition acquired like Beats, but basically Beats by Dre has these Studio Buds that are a Bluetooth headphone. It is a wireless headphone that you connect to a device. Pretty straightforward. Now the problem, like any other protocol, right, it could have vulnerabilities that could allow somebody to get maybe code execution or maybe deny or spy on the headphones, which on its own in a single case is a big deal, but not that surprising. That can happen. But what's crazy is, again, this came out last week. If you dive deep into the actual sources of this article, they reference another article that came out over a year ago. Bluetooth flaws could let hackers spy through your microphone. So this article is just the publicity on Apple patching and fixing their version of the bug. But this is research that came out a year ago from this research organization, ERNW, the Insinuator, and they published this vulnerability in not just one pair of headphones or two, an entire chipset that multiple manufacturers depend on to produce headphones that I still can't believe didn't get talked about more. Like, I'm just now hearing about this. As you can see, right, the list of headphones is large to include some pretty big players like some Bose headphones, some Jabra headphones, some JBL headphones, Marshall, a lot of those, Sony, a lot of Sony. The list goes on. What is the vulnerability? So there's this company called Aroha. I'm just going to say Aroha. That's probably wrong. I'll also speak a little bit of Spanish with Aroha. Aroha, so C's, system on a chips, which basically are the chip that is doing the Bluetooth, right? It is a controller that is meant to do the communication to speak Bluetooth. It is a Bluetooth system on a chip. Now, when you are a manufacturer or somebody that wants to develop with these systems on a chip, what's going to happen is the company is going to give you not only the chip, but the SDK, the software development kit that allows you to write your code on top, right? It wouldn't make sense for them to hand you like the chip and a data sheet. They have to give you something else to work with, right? They have to give you the actual code that allows you to talk to the chip, to give you abstractions to actually use it. Now, here's the problem. That SDK, the one that all these headphone vendors depended on, has these three vulnerabilities. Missing authentication for yacht services. I'm not going to say it again, but just I thought that was funny. Missing authentication for Bluetooth, BR, EDR, and critical capabilities of a custom protocol. This is where it gets in, like, again, the world of embedded devices. I've made videos on this. I have another video coming out on like just random Temu embedded shit. The world of embedded devices never ceases to amaze me in how they are somehow unable to just have basic software development lifecycle practices to like disable bad features going out to the public, okay? And I'm not trying to shit on any companies, I'm really not, but like the stakes are so high, not in like the headphone space, but in like the IoT, OT space. Different video, different conversation, but still, what is vulnerability? Okay, so the research started when this organization was doing research on this thing called the Orcast Transmitter PC configuration tool, which, mind you, is a USB traffic tool, right? Literally, it is a tool meant to configure one of these chips, an application that uses an Aura chip over USB. So like on its own, you're like, okay, it's USB, who cares? Turns out, this same protocol over USB that can be used to configure the device is also accessible over Bluetooth transport. Bluetooth, by the way, has two kind of like transport modes, GIAT and RF-COM. I'm not like a huge Bluetooth expert, but I know these are like the two main transport channels that exist for Bluetooth. And this protocol is accessible over Bluetooth. Also, it's accessible without authentication. If you're a developer, one of the easiest ways to stay ahead of vulnerabilities in your code base is knowing where and why your code breaks in the first place. And that's why today's video is sponsored by Sentry. Sentry is an easy-to-use drop-in application monitoring solution that gives you visibility into where your code breaks and why it breaks. An application monitoring software considered not bad by millions of developers, me being one of them. The reason I like Sentry, by the way, guys, is it is so easy to use. Like, it literally, all you have to do is make a new project. You click on the kind of project you have. I have a Django backend, I know, sue me. And then Sentry gives you the exact commands and like 5 lines of code it takes to actually implement this SDK into your project. project. From there, you get a feed of issues that are happening in your code base. One that I found that was pretty useful for us actually was in the Low-Level Academy backend, we allow you to submit projects to our project grader, and it will automatically pull them off of GitHub. It'll grade them and then use that to give you a grade based on the project you're currently doing. And so we had an issue with one person who they submitted their project to the runner, and we actually weren't handling if GitHub projects were private gracefully, basically because it said that there was no project found at this URL. That was throwing an error in Python. It was raising an exception, and then Sentry picked it up. So now we went back, we fixed this issue, and now we more gracefully handle these errors. Again, things like this that you don't really think about are the issues that grow and grow and grow into bigger bugs that become security vulnerabilities. And this monitoring we put into the code base and found this literally for free. And Sentry supports a ton of different frameworks for both front end and back end. If you have a Next.js app, a React app, something running in just raw Node.js, maybe it's PHP or Laravel, any of these integrate in like 5 lines of code to Sentry. And guys, the best part is for a small team of 1, it's literally free to use. You can get up to 10 custom dashboards, alerts and email notifications, and error monitoring like I just showed you for free. So literally all you have to do is copy and paste this piece of code into your code base. I changed the URL for privacy reasons. Every time your program throws an exception or has some kind of error that you choose to log, this will throw that error into Sentry so your team has access to that dashboard so they can see what's going on in your code base before the bugs get too big and become vulnerabilities. Go to this link right now and you can do Sentry for free, integrate it to your project and see what errors Sentry picks up in your code base and find those bugs before they become vulnerabilities. Thank you for sponsoring the video, Sentry. Let's get back to it. Now, a simple protocol with some simple lack of authentication. What could be so incredibly wrong with that? Well, if you read the functionality of the race protocol, because mind you, it is a configuration tool, you are able to, over the air, within the range of a Bluetooth device, you're able to read the flash of the device, read the RAM of the device, and oh, mind you, write the RAM of the device. So what you can do is use this to read the RAM to get the current state of memory, to know kind of how the stack is set up, where all the different functions are, and you can just conveniently insert your own piece of shellcode and then inject one of the link registers or something to point back to your shellcode and hook the stack or whatever to get code execution on these headphones. Okay, so I was doing a little more research. I kept reading their write-up, and eventually they linked to a toolkit that they wrote that's called the Race Toolkit. So again, this is literally just a Python script that's able to interface over I think it's a Raspberry Pi Pico or Raspberry Pico to act as a Bluetooth interface to talk to one of these headphones and do something. Maybe it's on a Raspberry Pico. Let's see here. Sorry, it depends on you specifying a USB device or some kind of a CI, a host control interface to a Bluetooth device to talk to it. But what they very quietly don't talk about in this report, which I don't know why, because it's pretty badass, is this FOTA feature that they wrote in their toolkit. Firmware over the air. This command performs a firmware over the air, where is it? A firmware over the air firmware update. We re-implemented the photo process and have observed it during an update on our devices. Obviously, don't use this if you don't know what you're doing, because if you send it firmware that is malformed and does not boot, it will brick your headphones. But what does this mean? The ability for you to be able to push a firmware image over the air onto a device you also can wirelessly get remote code execution on means that this is a wormable RCE, meaning that if I have a piece of malware that I can shoot over the air, and in the malware is code to do other photo updates, it can inject itself into other headphones as people walk around. How did this not get more attention? This is insane. And what makes it even crazier is if you consider the average person, their tendency to update the firmware on their devices. Oh, and like the amount of devices we're talking about here. And again, this is just the ones that these people, these researchers went out and were like, oh, okay, this chipset is in this device and it uses this SDK, so it is vulnerable. There are probably other devices that are also vulnerable that no one is talking about, right? But again, you could write, yeah, I'm not saying to do this. I'm saying from like a defense standpoint, like literally this could be bad. You could write a wormable RCE that like targets this version, and in that malware, it knows to shoot other malware, other headphones, and there's just a network of headphones. Oh, I guess part of the thing you should want to know is like, what do you do if you get code execution on these headphones? Well, these headphones, right, they're just a Bluetooth interface, and Bluetooth connected devices are actually very privileged in a phone. Well, you can't just pair an arbitrary piece of headphone to an arbitrary piece of phone. If you were to do, for example, dump RAM command, let's see if I can find it, RAM. Yeah, if you want to read all the RAM from the device, you can dump the Bluetooth link table, which has the cryptographic keys that headphone is using to authenticate with the phone, and then you can pull those keys down and impersonate those headphones, and then suddenly you can eavesdrop on calls. You can submit any kind of command that a hands-free device could do on the phone. You could read their content. contacts, all of that stuff, just because the headphone has a bug. So by the way, this applies to not only a Bluetooth Classic, like the normal like paired and authenticated Bluetooth, but also Bluetooth LE, Bluetooth LO Energy, which is more of like the pub sub, like simpler version of Bluetooth. So again, like this is the kind of bug, by the way, when people are like, oh, is Black Hat dangerous? Should I bring a burner phone? It's like, no, actually, like the Black Hat and DEF CON SOC, the networks around them, like as long as you're not like using an unpatched laptop and going to DEF CON and Black Hat and connecting to all of the Wi-Fi networks, generally you're safe, right? No one is throwing like proximal iPhone iOS 0-day at you unless you're like a government official or a journalist, okay? But these kinds of bugs that are really not that patchable, they're wormable and they're wireless and no one really cares about them because they're headphones are like the ones that like you may actually see some nonsense going on at a con like this. I wanted to talk about this, just bonkers to me that we haven't heard more about this. And I guess we kind of did a year ago. Oh, part of the reason you may be wondering, like, why did it take so long for them to reveal this or to disclose this? So if you go to the actual, the timeline of disclosure, they emailed Aurora, whatever, March 25th, 2025. They did not get an email back from them until May of 2025, so 2 months later, and then there was no confirmation of an SDK update with a fix until June, and then they were waiting for a couple more bugs to get fixed before they went full disclosure. But just interesting that like it took a very long time. So December is when this research was published at 39C3, and then now it's getting a lot more heat because Apple finally pushed out an update for their version of the headphones that were also vulnerable. Again, this should have more attention. I'm not sure why it doesn't. Anyway, thanks for watching. I appreciate it. Love you. Oh, and by the way, if you use Sentry right now, you get $100 of free credits. That's 100 USD of credits. Go try it out. Okay, goodbye.
The Bluetooth device is connected successfully.